Hello, Mario. In this video we're going to take a look at the perimeter and area of a triangle. So here we have our typical triangle, ABC, base B, height perpendicular or 90 degrees to the base H. So perimeter of the triangle, P triangle, equals A plus B plus C, where these are the length of the sides. Typically they'll be in meters, but whatever unit they're in, as long as they're all in the same unit, we shouldn't have a problem with that. Now the area of a triangle, there are two formula. One that most people are familiar with is half the base times the height. Half times the base times height. And that equals, written in algebraic or maths terms, half BH. And that's typically in meters squared. The base is in meters, the height's in meters. Meters times meters, meters squared. Now there is another formula which we will look at a little bit more closely later on when we look at trigonometry, but worth mentioning here. The area of a triangle is a half BC sine A. Now to put that into sort of different terms, it's half the product of two sides times the sine of the angle between them. The sine is a trigonometric ratio available on your calculators, times the sine of the angle between them, also known as the included angle. So half the product, which means times, of two sides times the sine of the angle between them, also known as the included angle. Now, just quickly, and in a pretty agricultural way, shall we say, or rough way, where does the half come from? Well, if we take the rectangle, which we've looked at previously, a rectangle, we know that the area of a rectangle is equal to the length times width, or base times height, and we put that in there. Now if we took a triangle or drew a diagonal of the rectangle, in this case A to B, that would give us a right angle triangle with base B and height H. And you can see quite clearly that that would be equal to half the area of the rectangle. So the area of the rectangle, B times H, and the area of the triangle, half B times H. So that's where the half comes from. So every triangle can be, no matter what shape, it can be paired up with another triangle of the same to come up with a similar shape. So in this case a rectangle, but it can be a parallelogram, where the area is base times height. So that's sort of gives you a little bit of insight in sort of rough terms where the half comes from. Not purely mathematical terms, we'd need a much bit more rigorous examination to prove that. So let's see if we can put all this theory into practice. Alright, so here we have three examples. The first one, calculate the perimeter and area of the following triangles. The first one is fairly simply, we've got the three sides A, B and C, and the base, which is AC, the height at right angles or 90 degrees to the base, 4.091. So the perimeter of the triangle is A plus B plus C. It's the sum of the lengths of the sides. Fairly easily, that's 8, A is 8, B is 16, C is 10, add them together, hopefully, yes, we get 34 meters. So that would be the length round the triangle, or around the sides of the triangle. If we started at A and walked to B, from B to C and C back to A, we would walk 34 meters. Now the area of the triangle, for this case here, because the information we've got is the base and height, half BH, half base times height, which is half times 16 times 4.091. And that's equal to 32.728 meters squared. You can see that we've got the meters times meters gives us meters squared. Here we've got metres plus metres, so it's just staying with the metres. Now here's a second example. This time we've given the base there of AB, and the height is outside, or what I call outside of the triangle. So the height is not in there. There is other, that's the information we've given. If we were given the length of AC, if we were given the height from a base AC to B at right angles to AC, we could use that, and we should get the same result. So the perimeter of the triangle, A plus B plus C, is 3 metres plus 8.944 metres plus 5 metres, gives us a total of 16.944 metres. Noting there that we've got metres plus metres plus metres, gives us metres. Area of the triangle equals a half base times height, which equals a half times 3 metres base times a 4 metre height. 3 fours are 12, half of that 6, and it's metres squared, metres times metres. Now one of the things I must stress here is that we should always practice, first of all, having a diagram. When we do these, have a diagram with all the information on it, written on it, a diagram. Then write down our formula, fill in what we know, and then finally do all our calculations to come up with the answer. And this is what we should do. In an exam or something like that, we're going to get one example to prove to the examiner that we know what we're going to do. So if we were to just quite simply look at this, say for instance, and just write down 16.944 metres and 6 metres squared, if we got both answers correct, that may give us full marks for that question. However, if we made a slight mistake in our calculations, we would likely get no marks because we're not showing any evidence of what we know. So coming up, I possibly may give you some worksheets where we do just have the answer. If you can, I would try and show your working at some place on the worksheet, and that working would involve a diagram with information written on it, writing out the formula, get into the practice of writing out the formula, filling in what you know, and then doing your calculations. And this is recommended for this type of work, so that you're showing or demonstrating to your marker or examiner that you know exactly what you're doing. And that is very important. It's important that we practice as we intend to do it in the exam or test, and that's our ultimate goal at this point. Practice as you mean to go on. That's very important. Now finally, I've got this third example here, and I've chosen here a right angle triangle, and I've shown the angle at A. Now the reason I've done this is this will enable us to calculate the area using both methods, because the base and the height are the same. So first of all, the perimeter of the triangle, it's a right angle triangle, and the perimeter equals A plus B plus C, which I've, after that great indication there of what you should do, have omitted to write down the actual formula here, but I'm sure you can forgive me for that. So the perimeter of the triangle is A plus B plus C, 3 metres plus 4 metres plus 5 metres, 3 and 4 is 7, plus 5, 12 metres. Note it's metres plus metres plus metres, so it's a distance. Now, the area of a triangle, half BC sine A, I'm going to go with that first. So we're going to have a half times B is 4, C is 5, and the sine of 36.87 degrees. 36.87 degrees. And writing that out, that's a half times 4 metres times 5 metres times 0.6. So the sine of 36.87 degrees is 0.6. And we multiply all that out. Half of 4 is 2, 2 fives are 10, times 0.6, 6 metres squared. Now going back to our other formula as a check, and this shows you how they all work together and give you the same answer, which is hopefully what you would expect. The area of the triangle equals the half base times height. So that's a half times 4 times 3. Half times 4 is 2 times 3, 6 metres squared. Note it's metres squared because you've got metres times metres. The actual sign is dimensionless. It is a ratio, so it doesn't have any dimension. So the units are accounted for in that instance and in the bottom instance. So there you are, some very simple, a very simple look at the area and perimeter of a triangle. Momentarily loss of the thing there, but yes, there we go, the area and perimeter of a triangle.